So when we pick up here with 1.3, halfway through on example 5, well, we're going to start, yes, we could probably figure out a lot just based on what we have here, but I'm just going to throw it in our calculator so we're not spending a ton of that time. So pull out your calculators. We'll go in. Okay. Comes out kind of pretty looking, all in all. I'll do a rough sketch of what my graph looks like in case you don't have a graph today. That's okay. It looks roughly like that. If I hit trace, I can follow it along and we see that it is approaching that -4. My table's messed up, so give me 1 second. Okay, so as we look at that, what is our domain? Yep. Negative infinity, positive infinity. What is our range?
-4 to positive infinity.
Yep, -4 to positive infinity.
Wouldn't -4 be a parentheses?
That's what I originally thought, and that's what I have on my stuff. What am I not seeing?
So
yes, they have that asymptote here at -4. Okay, our second one up. Let's put it in. Did you guys already do that? Or do you need a second? The second one does have an x as the exponent. I did not type that into yours. It looks like you're just getting a constant. So I don't know how I messed that up, but just be aware. Okay, you ready? Do you need a second? Oh, I guess I should graph it too. I actually have it that way. Okay, my graph is looking roughly like this. Okay, we can do the same thing here, domain. Okay, arrange.
negative infinity to 5.
Yep, exactly. Same reason, thank you for that. Good job, guys. We're almost done. Are you feeling okay? Okay. Exponential, let's try that again. Exponent rules. Whew. We'll keep going. Okay, so when we have the same base, we add our exponents. When we have division in the same base, we can subtract. When it's power to a power, we multiply, and we see that b to the x is greater than 0 for all x. remember at that top part, we already said that that fee is going to be greater than 0. Okay. I am still working through your names, so I just did it quickly. I just threw them into my calculator to see what they look like. We know what our first one is going to look like. We've seen the cubic function. We know that it's going to be shifted down 1. When we do this to see what's my official thing say, see if it has an inverse, so we're seeing if it passes that horizontal line test to do it quickly, then we can just go through and we know that the first one will have an inverse because it's not going to intersect it more than once. So we're just using that. I'm not going to make you guys verify that we have inverses right now. The second one, let's go just to make sure that you know what it looks like. Let's put it in. We see we have x cubed minus x plus 1. Zoom standard. Okay, and so here we see that it would fail our horizontal line test. So we would say it has no inverse. Next one, you just have to make minor switches, a plus, and then switch to a negative for the, the 1. Just want to make sure, -1. We see again that this one would pass, so this would have an inverse. And then last but not least, x minus 3 divided by and once again you see that it would pass it. So this would have an inverse. Are you guys okay with that? We just did that quickly with the, oh, yep.
So to tell if it's inverse or not, you just have to see if it passes the vertical line test.
If it passes the horizontal line test. So if it passes the horizontal line test, we know it's going to have an inverse. Yep. Good question. Guys, okay if I go to the next slide? Okay, we're just using exponent rules, and so that's all you have to do here. So the first one has the same base. We just add our exponents to the 10. Again, on an AP test, you would not be expected to work that out. You just leave it just like that. For our next one, same base. Something that you will find out about me as the year goes on, my favorite numbers are 3 and 7, 37 and 73, and I will work them into many problems. Okay, suppose the half-life of a certain radioactive substance is 20 days, and there will be 5 grams present initially. Then, when will there be only 1 gram of the substance remaining? Okay, so we know that initially we have 5. Let's go at T0. Okay, and then at T20, that's the amount of our half-life, so it's going to be 5 times 1/2. I'm just going to leave it as 5 halves. Okay, so now let's see what is it going to be after 40 days. So after 40 days, I wrote 20 again. We know that that's going to be that 5 times 1/2 times 1/2. So looking at this, we can kind of develop that formula that we're going to be able to use. I could look at it here and see that this would be 1/2 to the 0, 1/2 to the first. And then I'm going to erase one of these 1/2s because we see we have two of them, which would be 1/2 squared. So coming up with that equation, we'd have y equals 5 times 1/2. And then we have to use our exponent to adjust for at times 0. We know that we are at, where that turns to 1, it'll just be 5. But at time 20, we have the exponent of 1. So we're going to then account for that in the fact that our denominator of that exponent will be 20. So at 20, that would make it a 1. At 40, that would make it a square as we go on. For mine, when I did this, there's multiple ways for you to solve it. I thought it'd be easier just to pop it into my graphing calculator and look where the two lines cross. So I put this in there, and then I put y equals 1, and I looked for where it intersects. There is multiple ways of doing this. I just think that was my quickest when I first went through this. So let's go through 5 times. And then you're going to use that second calculate button. Intersection. So when y equals 1, what is our intersection point? Where is this going to cross? You might have to zoom out multiple times because if it's not in your window and you're looking for the intersection, it will not calculate that. Anybody want to give that to me, or do you guys just want me to tell you?
46.44.
Yep. So we have that 46 point. And then again, just to be where we're preparing for the AP, we won't round it to 4.4. We'll go out at least 3. And you can either truncate it or you can round. So it was 46.4. And I just moved mine. 439. Thank you. It's like I just moved mine and it moved over to that 0.895. So we're interpreting it in time of this problem, and so it's asking when it's going to be 1 gram. Well, that would be at 46.439 days. Yes, sir.
Is it fine if you can just solve this like through logs?
Yeah, 100% fine. And then there's multiple ways of doing it. I enjoy logs. You could definitely do it that way. Yep. I just thought that this was the quickest way when I originally did it. Any questions? You guys okay with this? The last thing we have, E, the natural base. The natural exponent function, f of x equals e to the x, and then this is just an approximation. That's all I have on here for you is just this information. It's the last part of the slide, just to make sure that you guys remember this and what the value is.